missing digit here in a fairly large multiplication here, a 4-digit and a 5-digit number. And so I'm going to rewrite this in its Hindu Arabic form in 157. This is just an example to give you an idea of the motivation for our solution process here. But again, 157 is equal to 1 times 10 squared plus 5 times 10. We'll say, we don't have to. I'll just say 10. We can put 10 to the first if you want. Okay, and then plus 7, right? Now, the reason why this sum of the digits result works is because notice these powers of 10 when you subtract 1 are multiples of 9. Okay, so that is 10 squared. And y'all, let me just write 10 to the n, okay? 10 to the n, where n is a non-negative integer. 10 to the n is always congruent to 1. Is congruent to 1 mod 9. And that's real easy to see. For example, if n, the trivial case, if n is equal to 0, 1 minus 1 is 0, and 0 is divisible by anything, right? 10 to the first minus 1 is 9. 10 to the second minus 1 is 99, and so on, right? So that, here's our 2 and our 1 here. They're both natural numbers. And notice that what happens right here, in a congruent setting, this can just be replaced. When you just think mod 9, this is just the same as 1 plus 5 plus 7. Okay. Again, congruence is a lot like equality, but 10 raised to a power is 1 modulo 9. Okay, so literally, modulo 9, this can be replaced with this. Now notice right here, if you don't trust anything I just said, notice another way of looking at this is that this says that 9 divides 157 minus, what is that? 9 divides 157 minus 13. Let me write that down right up here. There's like 2 or 3 different ways to write down congruences, but the sum of the digits right here, the SOD, sum of the digits is 13, right? And so 157 minus 13, let me write that parenthetically here. And again, y'all, this is just a build up to show you how this is relatively easy to solve without doing tedious multiplication. Notice this is 144, and 9 times 16 is 144. This says 9 is a factor, is a divisor of 157 minus 13. Again, 157 minus 13 is 144, and it's divisible. Another thing to note here is that 13 leaves a remainder of 4, as does 157 if you divide both of them by 9. You guys can verify that, but this is sometimes called just remainder arithmetic. But the big import here is that you can get a congruence of the sum of the digits, and it's kind of a congruence reduction sort of thing. Okay, so let's get going. We're trying to find this missing number, missing digit D, and D is a digit, it could be between 0 and 9, it's in base 10, right? So we're trying to find this value D, right? Okay, well, we're going to use our little tool here, this part about modulo 9. That in English, folks, any number is congruent to the sum of its digits, modulo 9. All right, so that's what we're going to do right here. Now, y'all, and I won't say too much here. I did the work for the left-hand side. Since these are equal values, the remainder of this side has to be the remainder of this side upon division by 9, right? That's kind of what's going on. You can kind of forget that, though, as far as just the formality of it all. So you can see what I did right here, folks. I just summed up the digits, 31247, 31247. You can see what's going on here. Same with 1846. Okay, summed up the digits. Now, when you do the work right here, this reduces to, look, 1 plus 7 is 8. You see, you can do it over, folks. 1 plus 7 is 8. 1 plus 9 is 10. And, of course, that's all congruent to 8. All right, that's congruent to 8 mod 9. That's very easy. It's very easy to see. 80, or just 8 times 1 if you want to think of it. You don't have to think about what is 8 times 10 and leaves a remainder of 8. You can just keep summing the digits. The sum of a single digit is the digit, so 8 times 1 is 8 right here. okay? So we get this statement, okay? We get this statement to work with. And now we have to work with the left-hand side. You see, we know that since these two guys are equal to each other, the left-hand side sum of the digits also has to be congruent to 8, all right? And the rest of it's fairly straightforward. I double-checked this. Now, right here, didn't quite finish it, but all of these digits, 5 plus 7 plus 8 plus 1 plus 9 plus 6 plus 2, add up to 38. So y'all, right here, you would actually get, what is this? D is congruent. You would get D plus, what is that? 11. D plus 11 is congruent. That's a D, sorry. D, I added the digits there. It's congruent to 8. But notice that that is congruent. D plus 11 is congruent to 8. And then what happens here, this is, you can sum your digits again. You get D plus 2. Again, you're not having to do too many really big time calculations, you're just summing up digits. So D plus 2 is congruent to 8. And of course, we're talking mod 9. And then you get D is congruent to 6. Okay. And that does the trick, folks. So that means the missing digit, since digits are between 0 and 9, 0 and 9 inclusive, that means that D must be equal to 6. You know, that's a horrible 9, isn't it? My God. Okay, but that means that D has to be equal to 6. There's a lot of other, you could 15, but 15 is not a digit, right? So D has to equal to 6. There's an infinite number of solutions to this, but only one would work since digits are bound between 0 and 9. Okay, so in y'all, again, that's terrible. So this is the answer. It's the answer right here. D is equal to 6, and you guys can verify that up here if you want to. It's now you may say tedious. Damn, that was tedious. But you see, we only had to deal with addition basically when we did all this. Okay, and you could do it quickly if you're not doing a video on it. You just go through it pretty quickly by summing the digits over and over and over until you get down to manageable numbers that are less than 9, that is. All right, and so that is the answer. And y'all, I feel guilty here. This should be mod 9 right here, sorry. Mark through that. That's mod 9. I think you know that, but it's for some reason that erase thing doesn't work here. I don't know. It's weird. Okay, eraser. Oh yeah, there we go. Strange, isn't it? Okay, for some reason that doesn't go away. I don't understand it. But anyway, I think you get the drift. Sorry about my penmanship. That is the solution, and I hope you enjoyed.